In this video, we'll be taking up the Chapter 5 review homework sheet. I'm going to argue that most of these questions are pretty straightforward, so hopefully you didn't have any trouble with them. Okay, so for the first question, they're asking us what the amplitude is. They give us the max value as well as the min value, so it's pretty easy. Just take max minus min and divide by 2. As for the vertical translation, just take the max and min value, add them and divide by 2. So by finding the average, you're finding the vertical translation because it's also the equation of the axis, which is the middle of the wave. So it makes sense to average the max and min values. Write the equation of a tan function if the period is pi and the phase shift is pi over 4 to the right. So if the period of the tan function is pi, that means you didn't apply a horizontal stretch. Yeah, you didn't. I guess you can say you applied a horizontal stretch factor by 1, but that doesn't change anything. So since the period of tan remains as pi, then we have a k value of 1. So yeah, x minus pi over 4 because you shifted pi over 4 to the right. For number 3a, they gave us basically the beginning of the period and the end of the period, or beginning of the cycle and end of the cycle. So using those two values, you can determine the period, the horizontal length of one cycle, which is the period. So subtract and you find 23 pi over 12. And with the period, you can solve for the k value. Number 5, it's really a twist on a grade 10 question. You have a right triangle and you're solving for the distance from the person to the base of the building and expressing it in terms of cotan. So yeah, d equals 25 cotan x. Draw a very simple graph. And as x approaches 0, d is approaching infinity based on the graph. And what does that mean? That means as the angle of elevation approaches 0, then the distance from the building, the person must be standing very, very far from the building. Yep. Let's see. And if the angle of elevation is approaching pi over 2, which is pretty much 90 degrees, then the distance between the person and the building is getting very small. It's approaching 0. And you can see that from the graph, and you can see that from the right triangle. So either or, you can see these two relationships from the triangle, the right triangle, or from the graph. Okay, so for question 6, they gave us the equation and just asked us for amplitude, period, horizontal shift, and vertical shift. So I'll just show the answers. There's not really much to say there. Except for C, I guess. You can, don't forget to factor out K. And the amplitude, even though the A value is negative, amplitude is positive. Amplitude will always be positive based on what its definition is. Alright, so number 7, they give us a bunch of information and they ask us to write the equation. Let's see, a cosine function. So they gave us max value, min value, they gave us the period and the horizontal shift. So I was able to find the parameters a, k, c, and d, and then I can write the equation. For b, they just want us to graph. So I didn't have my graph paper with me, so I just gave a nice little sketch. I even gave the scaling for the x-axis. So if the horizontal shift is 3 pi over 4 and a quarter period is pi over 8, I change it both to a denominator of 8. So since that is the case, then I am going to have my x-axis scale be going up by pi over 8. Because if I do it correctly, then all 5 of these points that make up one cycle of my graph, they will lie where the grid lines intersect. Okay. Hopefully that's okay. All right, question 8. So one of the big ideas in this unit is solving trig equations. So question 8, question 9, I guess, yeah, all 9 to 8, 9, 10, 11 are basically all solving trig equations. And for all the questions, there are restrictions from 0 to 2 pi, I believe. So that's why I didn't do the 2k pi. I didn't study the coterminal angles. So for question 8 and 9, I didn't study coterminal angles. So I'll just show you the answers because these equations, I must argue, are very straightforward. And why will I say 8 and 9 are pretty straightforward? It's because we didn't use any complicated identities to help us solve these equations. It was just strictly rearranging. So question 8, you're just rearranging and isolating the trig function. There's really not much to say. And all these ratios are not clean, so I had to use my calculator for all of them. Now 9a, b, c, and d, you just have to square root both sides, so be careful, do the plus minus. And if it's plus minus, you're looking at answers in quadrant 1, 2, 3, as well as 4. Yeah, so yeah, question 8 and 9 are not very interesting, especially if you did the challenging homework, challenging trig equation homework sheet. Those are way better than these ones. But nonetheless, they're good practice. For question 10, we have 2 sine 2x equals 0, which means sine 2x is equal to 0. Now, unlike question 8 and 9, I did find all the infinite solutions and then pared it down based on what the restriction on x was. Now, why did I try to find the infinite solutions for question 10 and not for question 8 and 9? Because for question 10, I had sine 2x. Okay, so you'll notice that whenever I don't have sine x or cos x or tan x, then I start finding the infinite solutions. Another instance where I'll find the infinite solutions is if the restriction was something odd or something very, very different. If it wasn't 0 to 2 pi, if it was, for example, from 0 to 10 pi, I know I'm getting more solutions. That's why I need the coterminal angles to help me out. Now here, for sine 2x equals 0, I'm studying the zeros of the sine function. I know that sine is equal to 0 when it's equal to k pi. Now, if sine x is equal to 0 at k pi, then sine 2x is equal to 0 at k pi over 2. Anyways, just follow the algebra if you didn't see the relationship from the graph. So I got the infinite solutions, and then based on the restriction on x, I get these 5 solutions. If you did not find the infinite solutions, if you just did 2x equals 0, 2x, or 2x equals pi, or 2x equals 2 pi, you're just going to get 3 solutions, and you'll miss out on 2 of them. So I strongly recommend you, if you have sine 2x, you're going to get more solutions. And the only way to be 100% sure if you have all the solutions by the end of the question is by studying coterminal angles. It's really easy to write it, so make use of coterminal angles. They will really help you find all the solutions to an equation. And at the end of the day, if you're not sure, just sub these solutions back into the original equation and double check. 11, factor, and then basically solve for x. Not really that interesting. I do like the exact answers here. Now here, once again, I didn't do pi over 6 plus 2k pi or 5 pi over 6 plus 2k pi because I'm working with sine x. And the interval that was given to me for x was 0 to 2 pi. So I know there are only going to be 2 solutions because I know the sine function, the graph of the sine function from 0 to 2 pi very well. So my expectation is there are 2 answers. I don't need to do any fancy. I don't need to do anything fancy. I don't need to study the coterminal angles. But once it changes, if it was sine 5x, for example, then things change and I'm going to get more solutions. Or if someone said to me like sine a third x, I will get a different number of solutions potentially. That's when I need to study the coterminal angles and obtain all the solutions as opposed to just hoping for what I have is good enough. But here, I'm sure what I have is correct. If these are the correct answers, if these 2 are correct, I know there are nothing else because I know the sine function. You know what? just to prove my point, when I answer sine x equals half, a part of my brain generates this graph of sine. I am very certain there are two answers. Okay? If it was sine 3x, this graph will not be correct. And that is why I start studying coterminal angles. Okay? Now, saying that, you could add the coterminal angles every single time and still get the right answer. But I'm trying to save ourselves some time. Okay, so that was the review for chapter 5. Hopefully you didn't struggle with this page too much.